Right, we are here and we want to write down the proofs to these particular two trigonometric identities using de Moivre's theorem. Right, we need to prove that cosine 3 theta equals 4 cosine cubed theta minus 3 cosine theta. We also need to prove that sine 3 theta equals minus 4 sine cubed theta plus 3 sine theta. And we present the proofs as follows. Right, so to present the actual solution to these, we need to take note of the fact that if we have cosine 3 theta plus I, the sine of 3 theta, and this is actually equal to cosine theta plus I sine theta cubed, like so. And this here is actually what you call de Moivre. Right. This is what you call de Moivre's theorem. Okay, like so. Right, let's proceed right now with the actual solution, but also we perform here a binomial expansion. So this equals cosine theta plus I sine theta cubed. And this is cosine cubed plus 3I cosine squared theta sine theta. And this becomes also minus 3 here. Cosine theta by using the binomial theorem. Sine squared theta. Okay, and here we have minus I sine cubed theta. Okay, now we're looking at the real parts. So this is cosine cubed minus 3 cosine theta sine squared theta. Right, like so. And we have plus I into 3 cosine squared theta. Can write the one at the bottom. See. Right, let's just write it at the bottom here. Right, so we have that if we group the real parts. Right, so we have these particular real parts and we've managed to group them. These two. And then we have plus I into 3 cosine squared theta sine theta minus sine cubed theta. Okay, so we have the real parts and then the imaginaries. Okay, now what is the meaning of this? Right, so this is true, and this hence has the following implication. The implication is therefore that we have, if we have cosine 3 theta plus I, the sine of 3 theta. Right, we've already seen that by using the binomial theorem and grouping like terms, etc., real parts and imaginary parts, this is a cosine cubed theta. Okay, so we can see that it's cosine cubed theta minus 3 cosine theta sine squared theta minus 3 cosine theta sine squared theta plus I into 3 cosine squared theta sine theta minus sine cubed theta. Okay, this is what we have. And then now we proceed to compare the real parts and imaginary parts. So comparing. Right, comparing the real and imaginary. right, imaginary parts. Right. So you have cosine 3 theta. Right, so cosine 3 theta is going to be equal to this part here. It's going to be equal to cosine cubed minus 3 cosine theta sine squared theta. And then sine 3 theta is going to be equal to 3 cosine squared theta sine theta minus sine cubed theta. So write that one down. So cosine 3 theta is then equal to cosine cubed minus 3 cosine theta sine squared. What about sine 3 theta? It is 3 cosine squared sine theta sine cubed theta. Thus, right now looking at the fact that cosine cubed theta minus 3 cosine theta sine squared theta is actually what cosine 3 theta equals. So we write that one down and analyze that. Cosine 3 theta is equal to cosine cubed theta minus 3 cosine theta sine squared theta. Cosine 3 theta is cosine cubed minus 3 cosine theta, 1 minus cosine squared this. Okay, because sine squared is 1 minus cosine squared. So that cosine 3 theta minus 3 cosine theta plus 3 cosine cubed theta. And this now, if you add these two here, it's 4 cosine cubed theta minus 3 cosine theta. So cosine 3 theta is 4 cosine cubed theta minus 3 cosine theta. Also, we focus now we focus on the sine of 3 theta. And we know here that sine 3 theta is actually equal to 3 cosine squared sine theta minus sine cubed. You write that one down. 3 cosine squared sine theta minus sine cubed, which means that we have sine 3 theta is equal to 3. Okay, what is the cosine squared? It is 1 minus sine squared theta by using the Pythagorean identity or the squares identity. Okay, cubed here, theta. Okay, or here we have the cubed theta. So that the sine 3 theta, by expansion here, what we get? Which is 3 sine theta minus 3 sine cubed theta minus sine cubed theta. Meaning that the sine of 3 theta is equal to minus 4 sine cubed plus 3 sine theta. Okay, so this is what we get. And therefore, cosine 3 theta is equal to 4 cosine cubed minus 3 cosine theta. Sine 3 theta sine cubed plus 3 sine theta. So yeah, this is what we have. Okay, now this is what we have here. And we have been able to prove these particular identities using the results we know. We have been able to prove these two identities using what we call de Moivre's theorem. Okay, so yeah, we are done proving these identities, these two trigonometric identities using what we call de Moivre's theorem, and we're excited to have proven this. So yeah, thanks everybody for joining us and for watching, and goodbye to you.